Hello viewers, welcome to video number 92 of the channel MALACHEMPHILIC, and video number 92 is the 33rd episode of Chemical Thermodynamics, and the topic is problems on Carnot engine and Carnot refrigerator part 1. So in this video we will solve few problems. So let's get started. Now, before going to the problems, let's have a quick recapitulation of the formulae. Say, we know that for Carnot heat engine, this efficiency eta is equal to T2 minus T1 by T2, where T2 is the source temperature, all these things I explained, and T1 is the sink temperature. And once again, eta is equal to W net, that is net work done, divided by Q2, that is total heat absorbed. And again, W net is equal to Q2 minus Q1. So therefore, eta we can write it as Q2 minus Q1 by Q2. This is for Carnot heat engine, where work is produced. Now, Carnot refrigerator. For Carnot refrigerator, coefficient of performance beta is equal to QC. QC is the heat taken from the cold bath divided by W. W is the work done on it, and then one more, W is equal to QH minus QC. QH is the amount of heat which is released to the hot bath or high temperature heat reservoir. So, beta is equal to QC divided by W, means QH minus QC. This is the formula, and this is already we have derived. Once again, equal to TC divided by TH minus TC. TC is the temperature of the cold bath. TH is the temperature of the hot bath. So these are the formulae. By applying these, we will solve the problems. So problem number 1. A reversible heat engine working between 273 Kelvin and 373 Kelvin absorbs 746 joules of heat from the source. Calculate A, the work done, B, the heat given to the sink, and C, the efficiency of the engine. What would have been the efficiency if the temperature of the source were 573 Kelvin? So this is the problem. 4 parts are there in the problem. Now here in the Carnot engine, T2 is given as how much? 373 Kelvin, and T1 is given as in the problem, that is how much? 273 Kelvin. And what is the amount of heat absorbed from the source? That is Q2 is equal to 746 joules. These are given. Now we know that efficiency, this part C will calculate first. Eta is equal to T2 minus T1 by T2, right? So that is equal to 373 minus 273 divided by 373, right? So this difference is 100 divided by 373. So this value will come as 0.268, right? So C part is over. Now this net work done, W net, that is equal to Q2 minus Q1, and again eta, that is equal to W net divided by Q2. So, or from here what we can write? Or W net, that is equal to eta into Q2. So, eta into Q2, that means if we calculate, W net is equal to, what is my eta value? 0.268. What is my Q2 value? 746. So if we calculate, it will come out as 200 joules. So this is the, which part it is? What is the work done? That is A part. A part is 200 joules. So this is my A part. And this one actually my C part. Right? Now part B. Part B. See, already I have written W net is equal to Q2 minus Q1. Already I have written here. So W net is equal to Q2 minus Q1. So what I have to calculate in the B part? B part is heat given to the sink. That means this Q1 I have to calculate. So therefore from here I can write this Q1 is equal to Q2 minus W net. Right? So what is Q2? Q2 is 746 minus W net 200, right? So if we subtract this, value will come 546 joules. So C part, B part also we got it. Now the last one, what would have been the efficiency if the temperature of the source is 573? That means here T2 is equal to 573. Now once again we put the value of formula of eta. Eta is equal to this T2 minus T1 by T2. So 573 minus T1 is same, that is 273 divided by 573, and if you calculate, this value will come 0.052. So this is the last part. Now we'll go to the second problem, that is problem number 2. What is problem number 2? A kitchen refrigerator uses a Carnot cycle between the inside temperature 0 degree centigrade and outside temperature of 20 degree centigrade. Part A, what is the coefficient of performance? It is refrigerator, that's why coefficient of performance. Part B, if the refrigerator cycle is reversed, it would produce work. Now it will be Carnot heat engine which will produce work. Find the efficiency of the Carnot engine that would result by reversing the refrigerator cycle. Okay, this is the problem. So according to the problem, TC, that is temperature of the cold bath, that is 273 Kelvin, and TH, that is temperature of the hot reservoir or hot bath, that is 20 degrees centigrade. That means 273 plus 20, so 293 Kelvin. Now, coefficient of performance beta is equal to, we know that, we have already wrote the formula, Tc divided by Th minus Tc. So, Tc is 273. Th minus Tc, that is 293 minus 273, that means it is 20. So if you calculate, this value will come 13.65. So this is our A part. Now coming to the B part. B part means if you reverse the refrigerator, that means Carnot heat engine, which will produce the watt, then what will be the efficiency? So for Carnot heat engine, we know that efficiency eta is equal to source temperature, that means high temperature reservoir temperature minus temperature of the low temperature sink divided by TH. So TH minus Tc, already you know, this is 20 divided by TH. TH means temperature of the, now it is source temperature or high temperature reservoir, that is 293. So this will be is equal to 0.068 eta value, or you can say it is 6.8%. So these are the two problems. In the next video, I will discuss some more problems. Thank you.